All right, so we're going to do another optimization problem. And so I want to, this is on the back of your worksheet. I want to talk about just a different example of one. So we have two vertical poles, one's 5 and one's 15. Doesn't say which side's which, doesn't really matter. 5, 15. And a worker wants to support both poles by running a rope from the, they're 48 feet apart. I missed that, sorry. And they want to run a support from the ground to the top of each post. So there's going to be a support post in here, and they're being staked. We're going to stake both ropes at the same point. So there's a stake somewhere right here, and there'll be a support up to the pole and up to this pole. Okay, so that stake will be on the ground. Where would the stake be placed to use the least amount of rope? Okay, so what we want to minimize, least amount, we want to minimize this rope plus this rope, those two distances added together. Okay, so let's look at our situation. What we know, we need to put a variable in somewhere. So on this problem, if we call this distance x, the distance from the 5-foot pole, then because this 48 is the whole distance, that means the leftover distance is 48 minus x. If you knew what x was, you'd find that by subtracting, so it's the same way. Okay, so to find these two distances with a variable expression, we just use Pythagorean theorem. A squared, which is what the distance formula is anyway. A squared plus B squared equals C squared. Take the square root. So in this case, this is x squared plus 25 square root. And this one is square root of 48 minus x squared. That's the nasty one. Plus 225. So we have two different distances. We want to minimize those. Okay, we want to use the least amount of rope possible. Evidently, the support won't matter as long as that post is in between there. Okay, so our distance is what we're going to minimize. So we take the square root of x squared plus 25 plus the square root of 48 minus x squared plus 225. And you can multiply that out if you want to. We want to find where that derivative is equal to 0. So this is a great time to use your calculator. I do not want to find that derivative really myself. So I'm going to go and enter this into my calculator. And you got to be kind of careful with the second one, especially you getting your parentheses in the right place. So the first one I have is x squared plus 25, and I'm using, instead of the square root button, you can use it to the 1/2, or you can use the square root button, whatever. I'll do this one to the 1/2. And the second one then, plus, I'll do the square root button on this one. Square root, parenthesis for the 48 minus x squared. And I did not write that as squared in the right place. Squared should be right here. Okay. No edits. That's what we get. Okay, 48 minus x squared plus 225. And just make sure that it's going to give me this little, get the sillies out. Make sure that you have everything under there that needs to be under there. Okay, so if I graph that, still have my old window. I don't see anything anywhere. Okay, so I'm going to go back and make sure that, because I want to graph and see if I can find the max or min just by graphing and not even taking the derivative. So I'm going to make my window bigger because I mean, these are 48 feet apart. So I'm going to make my x's go bigger. I know I can't have a negative distance. So I'm going to make my x go to 20. See if we get to see some graph there. Nothing. So what you're going to find out is you keep messing with this thing. Pretty soon you're desperate and you go to Zoom Fit. You see what Zoom Fit has in store. Oh, there it goes. So Zoom Fit, the negative is you lose the axes. The positive is that you do get a graph. So it looks like the minimum distance is right here. So I'm going to calculate the min. I'm not even taking the derivative. I'm cheating. Go to the left side, on the right side, come back. 11.9998, so 12. So I know that x is 12. So how can I get that using the derivative? Okay, if I did take the derivative, so I have the derivative in my calculator. If I graph the derivative, where the derivative crosses the x-axis is where my answer is, where the derivative is 0. So I go change my window. Yeah, it's pretty good. Come here, derivative. It's still figuring. It's thinking too long. I'm changing it. You can go quit. I'm just going to make this go from 10 to negative 10 to 10. And then I know my answer is 12, so I'm going to cheat a little bit so I doesn't have to think as much. So here comes the graph. It's going to creep along here. And what happens is you're not HD, right? So you can't see what is happening there. But it's crossing the x-axis. It's going to come up. You might not be able to see it come up because it's right along there. So it ends up being a process of, it's just scooching along here, a process of narrowing down your window until you're not using up all your battery. It's going to cross right there. Do not write on your calculator. Slowly trotting along. So you say, well, that's not a good method. I don't want to wait for my calculator. So you could go to your table. And if you look at your table and you want to verify, every table start at 10 or whatever and go by ones. If you go to your table, you should see the derivative is 0 there. And the derivative went from negative to positive. Negative to positive means that is a minimum. Okay? So let's see where the stake should be placed. It should be placed 12 feet from the 5-foot post, or 43 from the 15-foot. And that's a wrap on this problem. Thank you for playing.